today's class. For this class, we're talking about the concept of shear force and bending moment. So in our study of this concept, we're talking about some basic technologies in the study of shear force and bending moment. So let's discuss the basic terminology in the study of this course. Basic terminology. So let's discuss the basic terminology in the study of shear force and bending moment. Number one there, please. Number one, beam. Number one, beam. So beam is one of the terminology in the study of what? Shear force and bending moment. Number one, beam, please. Definition, please. A beam is a structural member. A beam is a what? Structural member that is designed. A beam is a structural member that is designed for load. That is designed for load at 90 degrees. So a beam is a what? A structural member that is designed to carry a load. This, yes. To carry a load, usually at 90 degrees, please. A beam is a structural member that is designed to carry a load, usually at what? 90 degrees, please. So many please. Type of beam. Types of beam. Goodness. Alright, please. Type of beam, please. Number one there. Number one, we have the statically damaged beam. Number one there, statically damaged beam. Number two there, getting to the calculation now. So note that there are two types of beam. The first one is called what? Statically determinate beam. What that is what? Statically indeterminate beam. Let's go this beam one after the other. Let's have the first one there. Statically determinate beam. Let's have the first one there. Statically determinate beam, please. Definition. Statically determinate beam is simply a beam. Statically determinate beam is simply a beam whose reaction can be determined using the equation of static equilibrium. Statically determinate beams are beams whose reaction can be determined using the equation of static equilibrium. Using the equation of static equilibrium. Listen please. When I say the word static equilibrium, what do I mean? Huh?
That doesn't move.
I'm using it, and listen, no, I did not say static equilibrium. I said equation of static equilibrium. By the word equation, what do I mean?
It's equal to something. Equation. Equation. That's like the formula.
What's the formula? So now, I'm telling you now, what's the equations? Can you please list out the equation of static equilibrium? Yes, now summation H is equal to 0, summation V equal to 0. Moment at the point is 0. Those three are what? Equation of static equilibrium. So when I look for a reaction, that's what you do now. You look for summation H, that is direction of f of x, then f of y, then moment at the point. Those are like the concept of what? What's it called? Equation of equilibrium. So when it comes to what's it called? Statically determinate beam. There are three types of beam there. Number one, then we have the simply supported beam. simply supported beam. Number 2, then we have the cantilever beam. Cantilever beam. Number 3, we have the fixed, overhanging beam. So when it comes to the study of this one here, there are 2 types of beam there that goes with equation of static equilibrium. There are what? Simply supported beam, cantilever, and overhanging beam. So we have this one here. Suppose I meant to master diagram for this, but I didn't show diagram for this topic, right? You know diagram for these beams. If you see a simple supported beam, how do you know it's a simple supported beam?
Yeah, just.
It has what? A beam and what? 2 supports. I mean now, for cantilever, how does it look like? The end does not end to support a beam, but one at the end and one at the somehow middle. I mean, for overhanging, how does it look like? Sorry. Okay, for overhanging, how does it look like? Abi? No problem. Number 2 is, let us discuss statically indeterminate beam, please. Let's discuss statically indeterminate beam. Definition of this. You know, I said this one is a type of beam that what? Whose reaction can be done using what? The equation of what? Equilibrium. This one cannot be determined this. So we become what? The opposite. So definition, this is a beam whose reaction cannot be determined using the equation of static equilibrium. So you have heard the word equation of static equilibrium. There are 3 equations of static equilibrium. The first one is what? The addition of all horizontal components must be equal to 0. The second equation of equilibrium is that the addition of vertical components must be equal to 0. Why the third one is that moment at any point must be what? 0. I'll give you the note very soon now. So I have this one here. So when it comes to this one here, there are 3 beams there, ranging from the same supported beam, cantilever, and overhanging. For this one, there are 2. We have continuous beam and fixed beam. So for this one here, we have what we call the continuous beam, and number 2 there is called the fixed beam. So we have these 2 types of beam that falls under this category here, right? Is this still working? Is the camera going? Let me check.
This one is working.
Really?
Yes.
Okay.
This one is that we have to come
Alright. Alright, look at this. So here's what the first when it comes to the study of this man, we said we have terminology, right? Yes. The first one is what? Beam. Let's go to the second one called load. Number 2, the second terminology is called load. So now when it comes to this load, there are several types of load, right? But for that, let's define load. What's load, please? What's a load? What's a load? You said? Stop now. Downward force, Abi. So tell me that a load cannot act upward, Abi.
No, the load can be defined as the force attracted on an object.
Definitely. A load is simply a force that acts on a structural member, please. A load is simply a force that acts on a what? Structural member. It's represented by P. It's represented by P. So we use P to represent load. Somebody please, types of load. I said a load is simply a structural member. Sorry, a load is simply what? A force that acts on a what there? Structural member, please. Is represented by P, please. P. F is for what? Force. P is for what?
Load.
W is for what?
What?
Really? What?
Wait.
W for what? M is for what?
Mass.
V is for what?
Velocity.
U is for what?
Unitary velocity.
Really?
Initial velocity. Initial velocity.
So, is there anything like uniform velocity?
Initial. Initial velocity.
Initial what?
Velocity.
Aha, it makes sense.
Yes.
Look up this. Type of load, please. So, very please. Types of load, please. Type of load, please. Number one. Number one, please.
It's going.
This one, man, I don't trust you. Listen, aside from everything, it's not everything that I'm watching this thing. So it is everybody worldwide, right?
Don't worry.
So please, let's
Do like this.
alright, look at this. Types of load, please. Let's call the several types of load, please. Number one, we have the concentrated load. Number two, we have the distributed load. Please. These are the two main types of load we have when it comes to study of what? Shear force and bending moment, please. Alright, look up this. Look up. Let us call this man. What do you mean by concentrated load, please? What do you mean? Point, Abby. Now listen, what's an hypothesis, please?
Hypothesis.
Listen, we have hypothesis, we have law, we have theory. True or false? Now listen, what's an hypothesis?
Like theory that is not yet proven. Theory that is not yet proven.
Look at this. What's an hypothesis? Listen, an hypothesis is a reasonable observation that is put forward to solve a particular problem, but has not been proved either what wrong or correct by other scientists. Listen, hypothesis is what? A reasonable observation that is put forward to solve what? A particular problem, but has not been proved either what wrong or correct by other scientists. Now look up, we have point load. Sorry, this one is called constant load, also called what? Point load. So a point load is a load that acts as a put. Now in real life, does it exist? We said a point load is a load act at a point. In real life sense, does that exist?
Yes.
Where? They are doing their picture. Where? How is it possible for a load to act at a point? You have been a beam like this, a beam this way, and the load is here. How is it act at only this point? Is it possible? Check your buildings. Is there any load at the point? They are all distributed. They are all spread. Have you now? Makes sense. So there's not like, for calculation's sake, that's how we brought in this concept. But in real life sense, does not exist because you don't have a load at a point. Look at your beam. You can't have only one beam on a station. For a structure, you can't have one beam there. True or false? It will collapse. So you need what? Several beams to what? Carry that load. And that load is, oh God, that load you are seeing beam carrying. That is beam carrying. Is that load in a point or spread out? It's spread out. So it does not exist. You can't see a load in a point. But for calculation's sake, we discuss this concept. But majorly, all structures are in form of what? Uniformly distributed load. So let's start with the first one here. Definition, please. Definition for the first one. This is also called point load. This is also called point load. It's simply a load that acts at a point. Point load. Load at the point. That's the definition. This is a load. This is also called point load. It's simply a load that acts at a what? At a particular point. That's what it is. A load that acts at a particular point is what? A point load. Draw the diagram please to illustrate point load. If I have a beam this way and I have a force of a half, a load 1, 2. So this is what we refer to what? A point load. A load that acts at a particular point. Number 2 please. Distributed load is number 2. Distributed load, definition please. This is a load that is spread across a structural member. This is a load that is what? Spread across a what? Structural member. Now when it comes to uniformly, when it comes to the load, there are 2 types of what? Lifted load. We have what we call the uniformly lifted load, that's UDL, and we have uniformly varying load, that's what? UVL. So types of this man here, number 1, types of distributed load. We have 2 types of lifted load. Number 1 there, we have what we call the uniformly distributed load. Load, and next up we have what we call the uniformly varying load. Alright, let's call it this. When it comes to UDL, what's UDL? Please, what's the meaning of UDL? What's UVL? So you listen. UDL can be represented in 2 ways. So I'll give you 2 types of load. Whenever I say those types of load, we use what? UDL to what? Represent them. So let's start with the first one. Observe for the first one here called UDL. How does UDL load look like? If I have something, if I have something of this nature, observe, I have a beam this way and I have a load this way. This load is what? It's called what? A uniformly what? Distributed load. It can be in this form or in this form. Observe. Either in this form or in this form. This is what? This is what? A uniformly what? Distributed load. So if I see this one on a structure, you are seeing a beam having this kind of load. This one what? A uniformly distributed load. Please note that, very important. The second one is called UVL. How does it look like? Majorly, there are 3 diagrams for representing UDL. But for a level, I just draw out 1. But look at the other 2 exist. What's the first one? We have a triangular load. Look up. A triangular load as this. This is what we call UVL, uniformly what? Varying load. There are 3 numbers. So this one is called a what? A triangular load. So whenever it's something like this, it says what? It's other what? Uniformly varying load. Aside this one, we have what we call the parabolic load, right? We have parabolic load and also one type of load like that, but we don't need that one. Just note these 2 types of load. Anyone in this form is called what? The UDL. This one is called what? The UVL. So ready please. So ready. Are you writing? Sure. Shall I continue? I should. So know this type of load is very important. Number 1 beam, number 2 load, number 3 now. Number 3 way to. No. Like I'm saying that there are terminologies in this topic. Number 1 is beam. Number 2 is load. Let's go number 3 now. Alright, look up. Let me explain this. When it comes to a structure or a beam or perhaps, yes, look at this place, look at this thing, the structure here. This one can stand on its own. Can this man stand on his own? No. What's on this man? This one, Abi. This two, Abi. So it means that if this thing needs to what? A support, Abi.
Yeah.
Now, the third technology now you consider that is what? Support system. So in engineering, majorly in civil engineering, mechanical, what have you? When it comes to this shear force, there are type of what? A support. We have the what? Pin support, roller support, and what? And the fixed support, right? There are support there. So I'll give you the support now, and the reaction produced by each support, please. Number 3, please. Alright, number 3. Number 3, let's discuss the third technology in the study of shear force and bending moment called support system. Look at this. When it comes to support system, there are types of support. Number 1 is called the pin support system, also called the knife edge support. Number 2, we have what we call the roller support, right? Number 3, then we have what we call the fixed support. So these are the 3 types of support we have. We have the pin support, roller, and what? Fixed support. So let's look at the diagram. So if I see a pin support, how do I know it? If I see a roller, how do I know that this one is a roller support? How do I know this one was a fixed support? Let us call the place. One after the other place. Number 1 there, we have what we call the pin support. How does it look like? If I have a look up, if I have something of this nature, observe, this man here is called what? A fixed support, please. Whenever this down part is being shaded in this form, it's called what? A pin support. It's shaded in this form. It's called what? A pin support. So secondly, for roller support, number 2, for roller support, we have something of this nature, a roller in this nature, something like a tire, right? So we call it roller. Now, here's not the real life application of this man. Look up, here's the real life application of this man. What's the application? For a bridge. A bridge has another support. Sir? 2 support, Abi. A bridge has 2 support, Abi. One at the beginning, Abi, and one at the what? The last part. You know that it has something of this nature. A curve like this, Abi. So a support is here. Support is here, Abi. Now, my question now is that what kind of support is there? Is it pin, roller, or fix? Huh? Wait, whoever said that girl, she said roller. So it means that if I put roller here, all the bridge go, it will be going. The bridge will be moving, it will be going. So this man here is wrong. I can't have roller here. At the end of the day, bridge will come auto. Climbing bridge, I don't move into the bridge. So now the idea is that what kind of support? Fix, Abi? Listen, it's telling me fix. Either you call it pin or fix. They place somehow the same row. So look up, like if I put pin support here now, or perhaps call it fix, I fix this place here now. You know that in life, listen, when heat is applied on any material, what happens to it? It will expand. Now you put fix here now, fix. Do you know that big expand? Do you agree? Yeah. So if it's not to expand, now all happens is because I put fix, all happens to it to break. So what kind of support are you going to put there? A pin and what? A ruler. A pin and what? A ruler. So that line is what? In case of what? Expand. It will expand and what? Contract back. So for a brick is meant to have what? Support. One pin and what? Roller. So in case of expansion, that roller will move a little bit. But that pin is what is there. What is pin? Expand is just break. That's the concept, please. That's the concept. So this one represents what? A pin support. This one was a roller support. Why a pin support looks like this, please? I have a fixed, what's it called? support looks like this place. Over 3. Majorly, fixed support is majorly applied. No, you have AC. AC is fixed on a particular wall. So that kind of support is called what? A fixed support. A fixed, what's it called? A fixed support. Alright, look up please. Look up. Look up. Look up. What's free body diagram? What's free body diagram? Free body diagram. Hey, and in this course. Listen, look up. What do you mean? Free body diagram. Yes, what do you mean? Free body diagram. What does it mean? Put down, definition. Put down. Write down. Let me define this for you, please. Free body diagram is simply a diagram that shows all the external forces acting on the structure. Free, F-R-E. Free body diagram is simply a diagram that shows all the external forces acting on the structure. Now look up. So we are saying that now, for any structure or perhaps any beam, at least you should have what? A piece of water and what? A glass of hot. Right? In case of what? Expansion. True or false? True. Now look up, let me show you something. Let's say I have a same piece of water beam as this. Let's say I have a piece support here and what? A roller support here. I just now. And I have a point load here. This way. Look at this diagram here now. I have support. What is it? Pin and what? Roller. Now, if I want to do my free body diagram, it means that I will change this one to what? An external forces. Are you now? This one here, this support has a particular force. Imagine, let's imagine something this. I have 50 kilonewton as my force here. Act on this beam. What am I expecting? I'm expecting that these two people here can carry this load, right? So, what will be the value for these two people?
It should be equal to the value of the one.
What's the value? 25. So this one will have what? A power what? 25. And this one what? 25. So what? Overcome what? This 50. Exactly. So it's kind of like, let's say we have Gabriel here carrying this load here, and we have Ibrahim here carrying this load here. If this load acts on what's it called? On their head this way, this one will act on their head. If these two people, let's say for instance, this one has 20 kilonewton as his own force, this one has 2 kilonewton. Please, can I carry this weight? They will collapse. I mean, so we expect that they would have what? 25 and what? 25. That's the concept, please. Now listen, I branch this place because of how to explain the concept of what? Free body diagram. So note that when it comes to what we call free support, the free body diagram there is true. We have a vertical what's it called? Force and what? Horizontal force for a free support. While a roller support has just what? Just one vertical. Please note it that the free body diagram for pin because what? These two. For roller because what? Just one. Why for fixed? Fixed has both horizontal, vertical, and what? And a movement. Please note that the free body diagram for each support. For pin, I have what? Two support, two reaction. That's vertical reaction and what? Horizontal reaction. For roller support, I have what? Just what? A vertical reaction. While fixed, I have what? Just what? 3 reaction. Ranging from what? The vertical, horizontal, and what? And movement. So when it comes to movement, what's movement, please? Force times distance. True or false? Alright. Now, with all this thing of our discuss now, let's start solving problems under shear force and bending moment. Example 1, please. Example 1. Let's start solving past question, please. Under this man. Answer on the board, please. So I wait for like just 1 minute. Answer on the board. Let's draw shear force and bending moment now, please. Alright. Let me copy the figure. I have this one here. Look at this. Look up, please. Look up. Let's draw the shear force for this man here, and bend moment diagram for this man. Now, when it comes to looking for shear force and bend moment, you first start with what? Look for what? The reaction of what? Each support. So let's call this one here. Let's call it point A and what? Point B, please. And call this point 1, 2. Call it point C. So we have point A, B, and what? Point C. Look up. I will not come back. Just listen. We said when it comes to drawing shear force and bend moment, your first is what? Look for what? Reaction. Now, my first is now I put that I will write out what? Draw what? The free body diagram. So look up. I'll have that. The free body diagram becomes what? This is what we big support. Are we? Yes. How many reaction does it have? 2 reaction, Abi? Yeah. One vertical and one horizontal. So I will have something of this nature. Observe. So because what? 1 vertical and what? 1 horizontal. True or false? That's for this one. How many reactions has 1, Abi? So I have 1 here. Now observe. We said. How far John go for? Listen up, please. We said figure diagram shows you what? All the what? Forces after what? On a structure, right? So the force that out of the structure becomes 1, 2, 3. True or false? True. This one comes down this way. Observe. That's 50 kilonewton. Now, this is my point A, my point B, my point C. Now, what's the best name to give this man and this man and this man? Call this one. Call it R-A-Y. Look up. Reaction at point A on y-axis. Reaction at point A on what? On x-axis. I mean now, you need a graph now, x and y-axis. So this is going up, that's vertical, that's y. So come from what? Reaction at what? Point A on y-axis. Reaction at point what? A on x-axis. What happens what? RBY. Reaction at what? Point B on what? Y-axis. So now, for me to now access the drawing of the shape of element, I need to look for what? RAY and what? RBY. Why? Because I know that kind what? Carry the load. It is not carrying any load. No. So these are the two that carry what? Load. I need to know their force for carrying this load. Which we know already that. All mass are busy. 25 E5. So RAY was 25 Abi? Yes. 25 Abi? Yes. But how to calculate for it? I just show you how to assume. Look up, I'm having 50 kilonewton after this structure. This one, RAY is carrying it. RAY is carrying it. We know that for 50, I will have 55 and what? 55 for balancing sake, right? Let's say I don't know it's 55. How do I calculate for it? Your first step is that, look at this beam. We said for a simple supported beam, overhanging beam, cantilever beam, you can use what? The equation of what? Static equilibrium. Are you now? So what's the first condition of static equilibrium? Number 1 is what? Summation H was what? Equal to what? 0. That is the addition of all horizontal components of what? Must be 0. So I will consider consider right force to what? Positive and left to what? Negative, please. It's very important at this point. I said your first task is what? Look for what? Solution H. That is addition of what? All horizontal components. So consider what? Your right is what? Positive. Left is what? Negative. Now look at this system here. This one. Which force are in this form? How many am I having? Which one is RAS? Look at this structure here now. This system of forces. Which force acts in this sense? RAS, Abi. So look at the solution of that component now include what? RAX. I said it for another one again. See, why is it not minus RAS? Why is it plus RAS? Because it's facing what? Positive direction. Observe. Please. So I have RAX now. It's now equal to what? Equal to 0. So it means that RAS is what? Is 0. That's what. Now, basically, for state of material, we don't consider the first condition of equilibrium because we know that what? It's the end of what? 0. Okay. Are you see now? Listen, in systems of material, what we call applied techniques and systems of material, they are both similar. When it comes to applied techniques, you must always do what? Solution H. But system of material, you know that after at the end of the day, it's what? You end up what? Adding zero. Right now, so for one of our view, I can ignore calculating for what? Solution H. Why? Because I know that what? So it end up what? Adding zero. But for now, let's start with what? Considering it is. So let's become the first law of equilibrium. Solution H on what? Equal to what? Zero. So consider this one. I'm done with this one. No problem. What's second condition? Summation what? V was what? Equal to what? Zero. So consider upward force what? Positive and what? That's what? Negative. Now let me check here. Both force are acting in this sense, in these two senses. How many are they? 1, 2, 3. Abi? Now, this is what? Upward Abi, the positive Abi. That becomes R-A-Y. Abi now, going what? In the positive direction. From what? What's next one? R-B-Y. That becomes plus R-B-Y. Why did the be that? Going what? In the positive direction. That's like the plus here. What's next? This one Abi? Downward. What will it be? Minus what? 50 kilonewton. Minus 50. Big equal to what? 0. What do we mean? Solution V is everything here. Equal to 0 is this one back. Any problem? Any problem? Any problem? No. Now look up now. I can't look for two things at the same time. R-A-Y, R-B-Y. In mathematics, why do we use equation 1? Look at them. Like in mathematics, there are some problems. Like, equation 1, what is equation 1, equation 2? Why do we do that? No. Why do we use, listen, I'm speaking mathematics. The teacher said, use equation 1, what is equation 2? Why do I use them as equation 1, equation 2? Why? What's the reason? Huh?
You can't find two.
Exactly. So I'm having R-A-Y, R-B-Y. I can't look at the same time. So what I did, I'll have R-A-Y plus what? R-B-Y. When you go to what? 50. From what? Abi?
Yes.
What is one here? What is one? Not the reason why now. Now, I'll consider the first condition of equilibrium. The second one, what's the third one? The third one is what? Moment at any point. So now listen. Here's my advice. Always take moment at point A at the beginning of the day, please. Are you now? Why? Because I want to do the action here. So I want to bring. Listen, question. Anyway, I'm taking moment from what? Equal to what? 0. Anyway, you're taking moment from what? Equal to what? Equal to 0. So now, taking moment at point what? Point A, right? As we wish now. Look up this. At point A, I'll have the summation n of A. But what equal to what? 0, I mean. That's the condition now. What's the first condition? Solution H. Second condition, solution V. Third is what? Moment at any point. Abi? So I'll consider what here? What I consider here? What I consider here?
Taking moment for it.
I'll consider clockwise what? Positive. Anti-clockwise what? Negative. Consider. No, when it comes to H, right is what? Positive. Left is what? Negative. V. Upward. Positive. Downward. Negative. But this one is what? Clockwise and what? Anti-clockwise. So let's start with taking moment. Look up. I'm taking that point A. It means that RAS and RAY is 0. That's meaning. True or false? True. So I'm taking that point A. It's that everything here is what? 0. What do we mean? Look up. When it comes to moment M is what? Force times what? Distance. True or false? True. Here is my own teaching or perhaps technique for explaining moment. If I take point at this point, it means that they are fighting at this point. Let's assume they are fighting. True. I mean, these two forces are the one on the left. I mean, in this system, there's no how. This will be interested in what's happening here. True. This will be interested in what's happening here. They'll go what this one, what's happening in this point. Now, how does this one move? Listen, I'm considering the fastest movement to to that point. We said, whatever at point A, everything is 0, no problem. Let's assume they are fighting at this point. 50 will come here and check, but what is the swap? This also will come and check what's happening. So for this one to move now, I said we are considering what? The fastest way. I mean, will this one move like this or like this? Listen, will it move like this or like this? In this one, like this, I mean? What kind of direction is this? This is what? A clockwise direction. Look up. So now, what do I get now? Look up. So my first time I consider this one. That becomes the 50 as the force. First is force times what? Distance. For this man to travel from here to here, what do you cover? What is the cover? Here to here is 10. Here becomes 5. I mean now. So what do you cover, please? 5. That becomes, sorry, times what? 5. Times 5. I'm done with this. We have considered this one already now. This is here. So you now put plus into again. This is the last one, Abi. Will this one now move like this or like this? In this is Abi. So when it comes to anticlockwise, what will be the value? A negative value, Abi. That becomes what? Minus what? What's the force there? RVY. Minus what? RVY. Times what? From here to here is what? 10. That becomes 10. Aside these two, is there another force there again? No. Equal to what? Equal to 0. What's next? Multiply the whole out there. 250, Abi. Plus what is what? Minus 10 RVY equal to what? 0. Then so you have 250 equal to what? 10 RVY. Let's get RVY by 10. By 10. What's RVY, please? 25. RVY. What? 25 what? Kilo. It makes sense. It makes sense. So it means that RVY is what? So that's your routine. Let's now get RVY. How? Into what? Equation 1. I mean now. So put RVY into what? Equation 1. What is equation 1, please? That's RAY plus what? RBY equal to what? 50. I mean now, it's same thing now. I mean, I can use this one. I want to. But this one is the best. Yes. So now what's my RAY? I don't know yet. So RAY plus what's RBY? 25. 25. Equal to what? 50. So what do I get here? RAY equal to what? 50 minus. What does that please? It makes sense. True or false? Yes. So I have this one here. So now let's not draw shear force and bend on it now. Yes. So yeah, put down. Put down. Right now. Put down. Oh, let's put this one again. Please put down. So there are 3 equations of equilibrium. Consider them when you are done. Summation H, summation V, and summation moment at the point. No, it works, please. Let it pass, please. Listen, question, please. If I want to draw shape and bend moment, what do I need to do first? Look for what? Reaction first. That's what? Your RA and what? RB. Those are the values. True or false? True. Let's now draw shear force, please. Let's draw shear force, please. Let's now. Are we through? Yeah. Are we through? Yes. Alright, let me show you this one. Just a please. Let's draw shear force and bend with this. Let's draw shear force and bending moment. Let's draw shear force and bending movement. Listen up. After point of reaction, RA and RB, what's next? Before you can draw a shear force diagram and bending diagram, do your what? Calculation. So very please. Calculating for shear force. Calculating for shear force. Look at this. Listen up, oh, listen up, oh. When it comes to shear force calculation, you are considering two things. Either you're reading from what? Left hand side of what? Right hand side. So I will always advise you to take direction from what? From left hand side. Why? Because we know already that upward is what? Positive, right down for what? Negative. So if you are taking it from his left hand side, consider what? Upward is what? Positive, down to what? Negative. But if left, upward is what? Negative, down to what? Positive. Yes. So when it comes to shear force, consider two things. Either what? Left hand side or what? Right hand side. If the left hand side, upward is what? Positive, down to what? But we are off of this one, right? So let's go with what? Left hand side calculation, right? So what does it mean? I'm having how many points here? A, C, and B. Abi? I'm having point A next to point C and what? Point B. Then I say, it's ABC now. Why is it ACD? I'm seeing A next to I'm seeing B forward. I'm seeing C forward before B. So now, how do you do your calculation for your shear force? Your first is that consider your point A. What's your RA? Is it going up or downward? For upward, what then? That's because what? 25 kilonewton. I'm done. For point A. For point C now, for shear force, repeat what you are having down back. Please. For shear force, anybody you are having up, repeat what? Repeat it down. So I have what there? 25. Let us consider C itself now. For C, that's what? 50. When that would have been? That's because of a negative 50. Thank you. What was of this? Minus what? 5 kilonewton. What's next? Put this one down back. That's the meaning. For shear force, whatever you have your value for the first one, repeat it down. Then consider that one come from. That was the value. Repeat it down again. So repeat this one down here again. 25. Consider your B. That's what? Upward. That's what? Plus what? 25. That's what? Here's the idea. For shear force always starts with what? A value and end with 0. That's the key. Shear force always what? Start with a value and what? Always end with 0. If you don't have 0, you are wrong. Shear force always start with a value and what? End with 0. But bending moment start with 0 and what? End with 0. Please. Shear force start with a value and end with 0. But bending moment start with what? Start with 0 and what? End with 0. If you are calculating for shear force, get the value. Having a value as 0 to 0. It's not what? But with 0. This is my shear force calculation. Let's now do what's it called? Bending moment calculation, please.
Chinese.
Look at this. Let's do some this. Listen up. I'm giving you for the look up. I'm giving you for shear force. Any problem here? Any problem here? No, sir. When it comes to shear force, what do? You repeat values, right? Now look up. For bending moment, what do we know for moment? Any point you are what? Taking what? 0. So now how many points here? 3 points are B. Point A, C, and D. How many points A, point B, and point what? And point C. Look up. For this one, you don't repeat value. For this one, you know what? You don't repeat value. Listen, please. For A, what do I get? Moment at point A is what? Oh my God. Zero. Please, is it like, is it 0 kilonewton or 0? 0. Is it 0 kilonewton or 0? 0. Listen. Is it what my unit here? Listen at me. So now, I'm having 0. Is it 0 kilonewton or 0? 0. Why 0?
Because it's 0.
Because it's 0 now.
Man is so lecture officer says 0.2. Now listen, I've considered for A, section A, Abi. That's what 0. Don't go and put 0 back here. Don't share force. For shear force, anything you have, what do you do? You put it down and consider that section. This one, don't consider that way. As for A was 0. Abi now. Listen, when you're taking moment of our very first explanation now, listen, no. I have a belief this way, Abi. When we took moment from here, we said this will come like this, Abi. This will go like this, Abi. Now, when I took moment from here now, look up, for my very own calculation, I took moment from here. Is there the force here at the back here? Now we're saying, listen, we're using the pattern of what? Taking it from what? Left hand side. So also yes, what? Left hand side too. So your clockwise will what? This one is what? Negative. Why? You are taking what? From what? Left hand side. Don't forget this. Left hand side. Left hand side. If I take it from right hand side, how will it be? That's what? Negative. Then positive. Then what? Negative. Positive. This is the same thing. You have the same answer. So far I'm taking my readings from what? Left hand side. So if I take moment here, I will not consider this one because not right hand side, Abi. So I'm taking what? Left hand side. So let's ignore this one now. Let's go on this diagram. Take a look at point A, that's 0, Abi. At point B now, look at point, sorry, is it B? It's C. Next up, I have B. It's B. Now look up. For your C, if I take that C, here is what? 0. True or false? True. Abi? Put your 0 here. But we are moving what? In the left hand direction, Abi? Left hand side, Abi?
Yes, sir.
I'm seeing a force here. So come here. Listen, you know what I'm saying? We're taking from what? Left hand side, Abi?
Yes.
At point A here, that's 0. Is there anything here? No. That will come here? No. That becomes 0. For this one now, here becomes 0, Abi. But this one can come here. True. Abi now? Sorry? If I don't put that at point A, that's 0, Abi. No problem. At point C, that's 0. But this one will come to this point. Any question? No. Huh? Any question? Let me explain again. Listen. When it comes to taking moments, at your point A, that's 0. But we're taking it from what? Left hand side. We know that when you're taking moment from, every force that day will come to that point, Abi. Now, so far I'm taking my left hand side here. For this one, is there any force here that can come here? No, now. There's no force that can come to this point. From the left hand side, Abi, that becomes 0. That's all. What to see? C is 0, Abi.
Yes.
But I'm looking what? Left hand side. I'm seeing a force, this one.
Yes.
Can come, Abi. So that becomes what? If it's a corner becomes what? RAY, Abi, which is what? 25. I'll have plus into 25 times what? From here to here is what? 5. Abi now? Yes. So times 5. Observe this one. Now listen. I'm moving what? In the clockwise direction. That's why. I'm moving like this. Observe. Let me kill this one. I said for many moments, first class at your point A is 0. I'm taking left hand side, Abi. Nothing is here, so I'm not going to say it again. So A is 0, no problem. Move to C. C is 0. But I'm seeing a force at the left hand side, Abi, which is this one. This one come here. So that becomes what? 25 times what? Yes, what? 5. That's it here. So I'm done with what? A and C. Abi now. So what my value here? What my value here? 125, Abi. Kilowatt. Kilo Newton. I'm done with this one. At point B now. For your point B is 0, Abi. At point B is 0, Abi. Because anybody comment on only 0. So at point B is 0 now. But when I go to point B, I'm saying what? 2 forces, Abi. So I come to B. So that is that. You say that when the number start with 0 and what? N is 0. Let us see if you N is 0 now. So now at point B now, 0 plus into this one here will come here. True or false? Yes. So start with this first one. So this one come in the proper direction, Abi. That becomes 25 times what? Times 10. But from here to here is 10. That becomes 25 times what? Times 10. I'm done with this. Plus into this one here, move what? In the proper direction, Abi. Negative direction, Abi. That becomes what? Minus 50 50 times what? 5. Equal to what? Equal to 0. True or false? Sorry? That doesn't, I mean, there's no equal to 0 there. So what's next? I want that B is equal to what? 0 plus, what was I here? 250 plus what? Sorry? Minus what? 250. No, what the value? 0. That's possible. Shear force start with what? 0 and end with what? Sorry. Shear start with the value and when end with what? 0. Bending will start with what? 0 and what? Almost end with what? 0. That's possible. Let's do that. Yes, now because look up. My first force is A, second is C, then B. Now, consider my B now, Abi. B is 0. True or false? True. But if I come from B, I'm moving left hand side, Abi. I'm looking at this one and this one coming here. So I'm taking this one first because it's what I'm saying here. The arrangement here now is A. Listen, the arrangement says what? ACB, not ABC. Right now, the arrangement is what? ACB, not ABC. So the first one is A. So take your A to this one C. Come back down of 10 to the one of 5. So I have this. 25 here. This is here. If you don't understand, I'll drop the video, right? So you watch. For those that are late, I'll drop the video. So you watch it. So I have this one here. That's all. Let's do our diagram, please. Let's draw diagram, please. Let's draw our diagram. Let's draw our diagram. Huh? For what? No problem, no formula here now. Just application, Abi. For this one, repeat your value, Abi.
Yes.
For this one, don't repeat value. Also that for this one, start the value and what? End with what? 0. Always end with 0. This one start with what? 0 and what? End with 0. Let's draw diagram, please. You are done already. You are done. Now, when you come to do your diagram, what do you need to note? For your diagram, listen. Your first step is what? Repeat the drawing. This drawing you are saying here. One draw it back here. So I have that drawing. This one here. 50, right? What's my, sorry? Okay. If I want to, I can draw that one back. This one. And what? And the ruler here. True? Now look up. I don't know how many points here. Point A, C and what? And B. Take this point down this way. Look up, oh. Take this one down this way and take this one down this way. Let's start. Take each point down. Now look up. You will draw an horizontal line at this point. Probably is 0, 0.0 and 0.0. It's not that the graph is like a graph, but not accurate, right? Just a rough graph. Look up, please. I have my origin here, origin O. Look up, O. The upper part for what? Shear force. Why down the what? For bending moment. So let's look at my shear force here. Shear force. Now look up at point A. Look up, O. At point A. Look up, O. At your point A, please, for shear force calculation. What's your at point? What's the shear force at point A? 25. Abi? Yeah. So let's assume that 25 is here. Let's assume that is here. Abi? 25 kilonewton. Sorry. 25 kilonewton.
Sorry. I'm going to assume in the diagram.
Right now, you can't. They don't give you graph. Just a rough sketch. A rough sketch. What we need that is what we need that. There's no how. Listen. They cannot give you graph. I'm not seeing it before.
He said something about measuring our value.
Hey, listen. It's in two ways. Listen, it's in two ways. Either your sister, either you come here now and say that who is the biggest value here? 25 Abi? Or then 5, 10, 15, 20, that way. That's what it's trying to say. But for this class, I think we're about that level. Let us assume this 25 kilonewton Abi. At point C, what is at point C? So minus come down Abi?
Yes.
So let's say this point was minus what? 25 kilonewton. Right? At point C, but B what's the 0? That's because of the point 0 here. True or false? At point A, 25 kilonewton. If you wish, 5, 10, 15, 20, no time, please. Then I'm using this. So you're going to be written at point C, please. That will be negative. So you go downward. That was must be 5. For point B, that's 0. Sorry, 0, Abi. That's my 0. Now listen. To shear force calculate diagram, you connect them in rectangular sense. For your shear force diagram, for a point load, for your shear force diagram, put down, please, put down. Right. For your shear force diagram, for point load, for your shear force diagram, for a point load, always connect them in a rectangular sense. For your shear force diagram, for a point load, always connect them in a rectangular sense. That's all, please. Please look up. Let's calculate this man. Look up. Look up. First, I'm having this one, Abi. Going to this one and this one, Abi. So I'll take this way. This one, this way. Down like this, Abi. Then this one was this way. Then this way. You have it here. This is a positive region, Abi. A negative region. If you want to, shade it. If you want to shade it. This is my diagram here. This is a shear force. Shear force. Shear force, please. Let's bear in mind this. Bear in mind always what? Below what? Your shear force. So let's take another region here. Region O, region O. Now, please check your bending moment, please. And what? As point is what? That's this is bending moment. As point is what? 0. What are zeros? Yes, 0, Abi. As point A, that's 0. As point B is what? 125. As point C is what? 125. Let's assume is what? Is somewhere here, Abi? Yeah. That's what? 125. True or false? True. As point B is what? 0. Now, listen. For shear force, for a point load, we said what? Connect them what? Rectangularly. Abi? Now, put that again. For shear force, for bending moment, for point load, for bending moment, under point load, please. For bending moment, under point load, connect them with an inclined line. With an inclined line. I said for shear force, for a point load, connect them out rectangularly. For bending moment, for point load, connect them out with an inclined line. How? Look up. Take this one to this, then this one down. This is what positive region of B. That's what it plus. Then and then shake. That's all. That's all. Yes. I don't. So for this man here, that's my shear force and bending. This plus, Abi? Yes. You know have plus and negative down. But this bending is not coming down. It's just always up. Just like positive here. So I have it for this one positive and this one negative down. That's what it is. So